Hello, everybody. Welcome to Co-Class. One second. Just closing my door so that the noise from my wife's office is not quite as loud as it is, and also to keep the cats out. So welcome to Co-Class. Let's start off by making sure we are all familiar with the things we can do on Zoom. So if you imagine most of you have had ample opportunity to check out Zoom at this point, but just to make sure you are looking at things I'm looking at, everyone should have the chat open. You don't have to use the chat, but sometimes I will write things, and more often you guys are writing stuff there and I will see it. So you can say hi to everyone, or you can just send a message to me or someone else if you want to. What else? Oh, someone made a noise. Let's see, I guess it makes a noise when you join. A few things. The other thing, so I don't know what the screen looks like for you, but I have a manage participants tab. That's, I might want to turn that off. Sorry. So I have a manage participants tab at the bottom where I can look at all you guys and I can mute or unmute you if I want to. But I think you should also have a similar tab. And at the bottom of that, there's some things that say like yes or no, or go slower or go faster, or there's a more, you can give a thumbs up or a thumbs down. And I can kind of see that. There's also a, so if you guys can go try, and I would like everyone to go try and give a thumbs up if you can. Awesome, good. Okay, you guys have got it. Looks like people are getting it. That is good. Also, if you want to talk, you're certainly welcome to. I wouldn't mind hearing your voices, but I understand chat is a little more comfortable for everyone. So sometimes with like as class goes on, when you guys start having questions, I forgot to fill my water. It might be easier to ask a question by actually saying words instead of typing something in, but we'll see as class goes along here. There was something else I wanted to say. Oh, there's also reactions at the bottom where you can give, oh, that's the thumbs up reaction as well. That's not the one I actually meant. So you can, there's also a little, it looks like they're holding hands. I guess it's supposed to be clapping. Yeah, can you guys give me a thumbs down? Oh, okay, I see. Okay, so those show up over there. I see. Okay, so the ones that are, I see. Cool. You guys are finding it right on. I'm gonna make this. Let's see. Okay, cool. Now I can see all of you. Good. Cool. Make my screen a little bigger so I can see more of the chat. All right. Oh, I can also make a poll. Let's see. I'm gonna add a question to the poll. Let's see if we can do this here. This is probably better done ahead of time. Yeah, this looks stupid right now. Yeah, type your question here. Who's your teacher? See, now this is definitely a not to do during class kind of thing. Rademacher, Rodriguez. I forget who the third one is at the moment. Oh, I've got it written down right here though. Carlson. So let me ask though. Let's see. I'm adding a question. Oh, no, I'm dumb. All right, I'm gonna close this poll. Maybe I'll try a poll later. Maybe. I don't know about the polls. Oh, my other screen here just got really less awesome looking. Oh, there we go. I did want to ask, how many of you have had class today? You can say, I don't know, you can give me a thumbs up on this thumbs up, the reactions thumbs up, or how about the, yeah. Camille, nobody else had class? That's fine. Oh, Jennifer, okay. Whose class was that? I know I don't know who your classes are. Whose class were you in, Jennifer and Camille? Rodriguez, Rodmacher, okay. Okay, so I'm guessing the third one, which is Carlson, hasn't met yet. Oh no. So everyone has had class? Oh wait. Oh, Rodmacher's after. I see. Okay. So what else? I wanted to test out a few things. So this is my second Zoom class of the day. So things are, oh, I know what I was gonna say. Just as like say this every class, I might forget, but whatever. Our class is being recorded. It's mostly just me being recorded. And then I'm gonna upload those videos to Canvas after class. So I don't imagine the one today will be all that helpful, but in the future, if there's stuff from these Zoom meetings that you want to go look at later, you are more than welcome to, and they will be posted on Canvas. I believe I did that for my first class. I haven't gotten anyone saying that they couldn't find it or watch it, so we should be good there. Also, the plan is after class, generally, after we talk about whatever topics or concepts you want to talk about, I plan on making some short videos, probably 5 to 10 minutes in length, just doing a couple of examples here and there of the same sorts of problems. I know I've already said this in emails and stuff like that. I don't like that. The computer is making too much noise for my personal preference, but I want to be able to hear you guys if you say stuff, so I guess I'll just deal with it. So the plan is to make videos doing examples of the topics you want to see. So I haven't exactly figured out how to do this yet, but if you have things you want to hear about, you could either tell me right now, you could send me an email after class, you could send me an email after your 17C class meets, or you could even start a discussion in Canvas and say, hey, for this day, these are the things I want to hear about. And those things could be, where did the topics go? Sorry, I had a whole list here and they just went away. There's Grant's webpage also has some good examples on it. I feel like I'm looking at the wrong one. That's interesting. Sorry, I'm looking around here. Where did you go? So at least for Carlson's class, I see, sorry, not Carlson. Oh, no, for Carlson. For Carlson's class, his syllabus kind of lays out what you guys are going to go over. He's got essentially chapters 9, chapter 9, chapter 10, section 7.6, then the first part of chapter 12. So it seems pretty doable. We're going to start off with functions of many variables, limits, continuity, partial derivatives. It's definitely different than this class has been in previous years because, again, we're using a new book. So we'll have to really kind of make sure we pay attention to what the teacher is doing in class and try and follow along with that. I might try and sit in on some of your classes depending on what time they're at. Oh, domain and range for multivariable functions. Sure thing. Yeah. So don't hesitate to type your questions in there. If you have typed something and I haven't seen it, please feel free to actually unmute yourself and say something and I can look at it. I don't always see the things right after that. But yeah, we can definitely talk about domain and range. Let me see if I can find, and I've got some examples just sitting around here. So let me take a look for a minute. Okay, lots of stuff. Cool. Where are you? That might be that one. Let's see. So also, in general, you know, as I'm getting used to this, it might be a little rough in the beginning, but hopefully this will get a lot smoother as we go along. That's maybe fine. These might be good. Let's look over. I got lots of things. Get bigger. Okay, let's look. All right, yeah. All right, cool. So domain and range. So before I get to domain and range, just let me make sure there's a few other things I want to make sure I go over. Let me change, let's see if let's open these windows a little bit more. Light, yeah, that seems okay. So I just want to make sure I'm going to switch over to my document camera for a section and ask you guys, how visible is that? Is it easy to reach? To be a little bit bigger? A little bit smaller? Probably not smaller. I see some thumbs up. I know you guys are used to my document scanner writing, and it's not always the best, but I will try to make it as excellent as I can. So in fact, while it's there, why didn't I do an example on the document camera? I wish my seat rolled a little bit better. So I'm moving around here. Let's, yeah. So let's see, I've got some examples right here. So let's do an easy one. So let's describe the domain. I'm going to try and write bigger and range of this function. F of x comma y equal to x squared plus y squared minus 9. So there we have a function of two variables, x and y. So for domain, we're still stuck with the same usual three kinds of domain issues. If you've got a square root, if you've got a fraction, or if you've got a logarithm, those three functions have things that are problematic when you're talking about domain. Here, we don't see any of those, right? There's no root, there's no log, there's no fraction. So we can say, okay, the domain here, now it's not the same as saying all real numbers, because it's not all real numbers. It's all possible coordinate pairs. Or you could say it's all of the real plane, would be one way to say it. Or all points x comma y in the plane. Or you could just say R2. All of those would be fine ways of saying what the thing is. So something else you can do, which I'm about to do, is I'm going to pin my video to the top so it looks bigger so that I can see what I'm writing or see how it looks to you guys. And I'm also going to mirror my screen because mine looks backwards to me right now. Maybe I'm going to unmirror it. I don't know. Video settings. Mirror off. Cool, now it looks right to me. Resolution on the dock camera, not great, but it is readable. So now, there's our domain. The range is where we have to be a little more thoughtful. So a lot of these range questions, a lot of these functions of two variables where you have to find the range, you're gonna end up having, often, not always, x squared plus y squared somewhere. And that's really helpful because we know that x squared plus y squared is always greater than or equal to 0. It's always true, right? X squared is always non-negative, y squared is always non-negative. If you add them together, it's always non-negative. And so then if I've got x squared plus y squared minus 9, I can say, well, I'm just going to subtract 9 from each part of this inequality. So x squared plus y squared minus 9 is greater than or equal to minus 9. So our range, our function can be as small as minus 9 and as big as however big we want. So here the range is everything from -9 inclusive up to infinity. The range is more normal. It's not pairs of coordinate points. It's just the output values, which are singular, not like two things, x and y. Sometimes we call these the z values. Although, yeah, there's also a stats thing. There are z values, which is totally different. So let's go. I'm going to go back to the other video wherever I can find it. There we go. Why? So, sorry, I'll go back. Apologies. So the reason I did that is because I was trying to look at the function, right? It's not so much that I set it to be bigger than or equal to -9. It's that I started with this, x squared plus y squared. And the reason I started with that is because I know that x squared plus y squared is always greater than or equal to 0. And then I was trying to get from that to the x squared plus y squared minus 9. So I subtracted 9 from both sides of the inequality to get x squared plus y squared minus 9 is bigger than or equal to 0 minus 9. And a lot of the times, these are going to kind of revolve around us knowing that x squared plus y squared is greater than or equal to 0. So let's do some more. And I think, so let's try, we'll do this next one on the board just to change it up. Let's see here. I'm going to go to the other thing. Again, I'll remind you, if I'm not seeing your questions, which is very likely when I'm at the board, don't hesitate to speak up. I'm going to move this over just a little bit. Yeah, everyone can still see that, right? Yeah, all right. This here is kind of in the way. Yeah, I'll move it even more. Go even more. Let's see here. Sorry, still getting used to things here. Yeah, that seems good. Now you can see the weird cat picture in the background there. Okay, pen. Good. Sorry, it's still a work in progress. So. This board is getting, wants to move too much. Okay, so let's look at another example. And again, I'm going to warn you, a lot of these examples are going to have an x squared plus y squared. I know, I wish my face was like, I mean, whatever, you might not care about seeing my face. It seems weird to me to be like not on the video. That's a little bit better. So let's look at this function. F of x comma y is equal to 1 over x squared plus y squared. Kind of want to make, fine, we'll do this first. Plus 1. Now this one, there might be a domain issue, right? The denominator could end up being 0. So we have to think about the denominator. So is there a solution to x squared plus y squared plus 1 equal to 0? Well, so I guess a good way to do this. So I'm gonna have you guys give me thumbs up for yeses and thumbs down for no's. Is there a solution to this equation? Thumbs up for yes, thumbs down for no. I want to see some thumbs. Good, I'm seeing some, I'm seeing some. I'm waiting, I'm waiting. Still a couple of you not giving me a thumb yet. See, this would be perfect for me to do. Oh, whoa, okay. Oh, that's cool. I want the chat back though. Sorry, I just did, come on, chat. Sorry, I've lost the chat. Oh, there we go. It's back. Okay. Just trying to make it lower. Cool. So, all right, I see a lot of no's. I see some yeses. So here's the thing, right? If I'm thinking about this, I know that this is always greater than or equal to 0. So can you guys hear that when it chimes in like that on my side? When I'm getting emails? I hope the answer is no. Sorry. Okay. Well, I'm going to figure out, I'll fix that for next time if I can. I guess I could just, I mean, you guys, so I'm going to, I guess I'll mute it. And then if you guys want to actually talk, I'll have to turn my volume back on. All right. So this is always positive or non-negative. So this plus 1 is always greater than or equal to 1. Another way you could think about it is you'd be trying to solve x squared plus y squared equals -1. No solution. So again, the domain, like the last problem, is everything. All of R2. All coordinate points x and y, where x and y can be any real number. Okay, so how about the range? The range is usually the harder part of these problems. Not always, but often. So the range is where you really have to think about modifying this. So here's what I'm going to do. I'm going to take x squared plus y squared and say it's bigger than or equal to 0. And then I'm going to mess with it until it looks like this function here. Just like I did in the previous one. Right? I subtracted 9 from both sides. I got x squared plus y squared minus 9 is bigger than or equal to -9. So first things first, I'm going to add 1 to both sides. So x squared plus y squared plus 1 is greater than or equal to 1. Just added 1. And then I'm going to do the reciprocal of both sides. Now, no, that's, so here's the thing. When you take the reciprocal of numbers, the inequality order changes, right? I know that 2 is less than 3, but if you take the reciprocal of both sides, 1/2 is bigger than 1/3. So whenever you do reciprocals of things and inequalities, you have to change the direction. So 1 over x squared plus y squared plus 1 is less than or equal to 1. Sorry, 1 over 1, which is still 1. Now, gotta be careful and write nicely. You might say the wrong range if you wrote this. You might end up saying, well, if it's less than or equal to 1, that means it's everything from -infinity up to 1. But we know that's not right. Because even though it has to be less than or equal to 1, this thing down here can never be negative, right? We already said x squared plus y squared is bigger than or equal to 0. So since this denominator is, since x squared plus y squared plus 1 is bigger than or equal to 1 and positive, the reciprocal is less than or equal to 1, but still positive. When you take reciprocals of things, the sign never changes. It always is the same as what it was before. So what our domain actually is everything from 0 exclusive to 1 inclusive. That's our range. I think I said domain for a second. That's our range. If you think about it, right, you can definitely get 1 by letting x and y both be 0. And you can get any smaller positive number by letting x and y just get bigger and bigger and bigger. But we'll never get to 0 because this fraction, well, for a fraction to be 0, the top has to be 0 and the top isn't 0. Okay, show you some more examples. There's one way to do it. Let's go this way. Bigger. seems like it's tighter. Oh, no, that's not cool. Okay, good. Also, I'm gonna try out different pen colors. I've heard most of them are pretty all right. Some people said the orange is not excellent. Other people said the orange is great. So we'll see. Also, I got black. You grab a black pen too. This room is too warm. Maybe I should open a window. Yeah, okay. Sorry, I am gonna open a window because I'm getting kind of hot. There we go. Sorry about that. Okay. It's mildly cooler outside. Not a lot. All right. This chair. This chair just put this chair over here. Cool. Perfect. All right. So, more examples. Oh, I have my computer on mute. Do I? Oh, like you can't hear me because. Okay, let me ask. Can you hear me right now? Can you guys hear me? Yes. Okay, cool. Teresa has a question.
So for Professor Rodriguez's class, when we were finding the domain.
The question she asked. Oh, you were like trying to say words. I am sorry. Go ahead, Teresa.
Okay. All right. Professor Rodriguez mentioned about having test points when we were testing for the domain. For example, we were given a function of f of x, y, and it was a circle. So he chose a test point of the origin, and then we plugged that into part of this one equation just to see if it's part of the domain or not.
Sure. So
where does that part come in?
Well, excellent question. So let's look at, we'll look at two examples. So let's look at this example, which was the next one. Yeah, good. So as I've said already twice, you're going to see a lot of x squared plus y squared. It's not exactly written that way here, but it still is an x squared plus y squared. Whenever you see this, you really want to think of this as 16 minus x squared plus y squared quantity. We really, really want those together if we can, if they happen to come out together. So let's find the domain. So the domain here, well, I need the insides to be greater than or equal to 0. All right. So I would prefer to have the x squared plus y squared be positive. I'm going to bring that over to the other side. You can also subtract 16 and multiply both sides with -1, but I'm just going to add different colors. I'm going to add x squared plus y squared to both sides. So now I've got the inequality, x squared plus y squared on the right is less than or equal to 16. Now, from our experience, we know that x squared plus y squared equal to 16. That's a circle with center at the origin and radius square root of 16, which is 4. So the idea here is that if we have an inequality instead of inequality, you're always going to get one side of whatever's bounded. So let me draw the circle. So radius of 4. Let's just do that. So there's my circle. Radius 4. And now the question is the domain all the points inside the circle or outside the circle? And the way you can tell, or I should say, the easy way you can tell is by testing a test point. So if you want to test, say, now often test point, I'm going to pick a 0, 0 because it's easy. So if I test 0, 0, does x equal to 0 and y equal to 0 satisfy this inequality? Well, yeah. If you plug in 0 for x and 0 for y, 0 plus 0 is 0, and 0 is less than or equal to 16. So this point is in the domain, which means that everything on that side, on the same side as that point of the boundary, is also in the domain. So once you've picked a point, if it's a success, everything in there is. If it's not a success, everything out there is. We also could have, if we wanted to, picked a different test point. Say we picked the point, let's say we picked 0, 5, which is up here. Well, if I plug in 0 for x and 5 for y, is the inequality correct? No, it's not. 0 squared plus y squared is 25. 25 is bigger than 16, not less than or equal to 16. So knowing that that point is not in the domain, we know that all the points outside of this boundary are not in the domain. So that's how we find the domain here. And I'm going to mess with this example in a couple different ways. Yeah. So I do want to talk about the range, though, because the range here is also interesting. Let's try the dreaded orange pen, see how it works. If it's a no-go, just let me know. So for the range, again, I'm really starting with x squared plus y squared bigger than or equal to 0. That's really, if I have an x squared plus y squared, that's my go-to. All right, now I'm going to, well, I want this function. So I want 16 minus x squared plus, so I want minus x squared plus y squared. And when I multiply both sides by -1, I have to change the direction of the inequality. So negative x squared plus y squared is less than or equal to -0, which is still 0. Sorry, let me see here. I feel like I'm getting some glare. Yeah, that might help a little bit. And now I'm going to add 16 to both sides. So now I've got 16 minus x squared plus y squared is less than or equal to 16. All right, so now here's the thing. I need a square root. So the square root of this is less than or equal to the square root of that. So it looks like my function, square root of 16 minus x squared minus y squared, is less than or equal to 4. It can never be bigger than 4. Right? You can definitely get 4 if x and y are both 0, but once x and y are something other than 0, they get bigger, which means 16 minus them gets smaller. So my function is less than or equal to 4, and similar to the previous example where the thing was always positive, square roots always give us positive outputs. So this is going to be bigger than or equal to 0. We can definitely get 0 by letting x be 4 and y be 0, or x be 0 and y be 4, so some other combination. So here our range would be 0 inclusive to 4 inclusive. So I want to change this one around just a little bit to show you guys two different things. Let's go. Is this the tight way? I don't want to make it too loose. Yeah, okay. Sorry, this board's a little, taking some getting used to here. You want it to be tight enough so that it doesn't like swing back and forth. But you want it to be so tight that it's hard to like undo it. Yeah, like it's not tight enough. Okay. Yeah, cool. So my sound is on, so if you have questions you want to chime in with, feel free. But I want to look at two similar but slightly different examples. In fact, the first one I want to look at is this. What if my function instead was the square root of x squared minus y squared, sorry, x squared plus y squared minus 16. So the same as the previous example, except kind of the insides are the opposite signs of what they were. Oh, sorry, you're confused by the range is less than 0? It wasn't less than 0.
Oh, sorry.
Right, in the previous example, the range was from 0 to 4. And that's actually something worth mentioning, though. Whenever your function is a square root, the very bottom of the range ever can be is 0, right? You can never have a square root giving you negative outputs for your range. For this one here, same kind of deal. For the domain, we're going to say that x squared plus y squared minus 16 is greater than or equal to 0, or x squared plus y squared is greater than or equal to 16. So we still got the same kind of inequality here. It's a circle again. It's this circle with radius 4. Ooh, yeah, there's something I kind of should have said before, but I'll say it this time. But here, the domain is everything that's outside of the circle. Right? If we test 0, 0, 0, 0 doesn't satisfy this inequality. Right? 0 plus 0 is 0, which is not bigger than 16. So it's not anything inside here. It's all the stuff. Maybe I'm going to draw this a little bigger here. Outside. So like, there's my range as a picture. Sorry, domain. I said range, I meant domain. So there's my domain. So here's the thing. While this is fine for the domain and is probably the more important part to understand, it's not usually how we write our answer. So the domain here, the way you would write the answer is all points xy that satisfy this inequality. It just feels kind of like a cop-out. So this is such that x squared plus y squared is greater than or equal to 16. That's really the only concise way to write the domain. I mean, I guess you could really write it as all the points outside of the circle centered at the origin of radius 4, but that seems terrible. Another more mathy way of writing it is it's the set containing all coordinate pairs x, y, such that x squared plus y squared is greater than or equal to 16. And what about the range? Interesting. Good question, James. I'm talking to myself a lot this quarter. So for the range, once again, same idea. X squared plus y squared is greater than or equal to 0. As mine actually ended up being a little bit different. X squared plus y squared minus 16 is greater than or equal to negative 16. Doesn't seem super helpful. Square root. Being bigger than or equal to the square root of negative 16 doesn't seem super duper helpful. So here's my thought process here. We already know that this x squared plus y squared is bigger than or equal to 16. Our domain said it had to be. So we already know that this is 16 or bigger. 16 minus 16 is 0. So we know that our range is starting with a low of 0. You can't be any smaller because square roots always give you non-negative outputs. And then how big can this get? Well, is there any limit? Can x and y be anything we want them to be? Aside from things that make them too small. Yeah, they can be anything. Right here, x could be 1,000, y could be 1,000. You have the square root of 2 million minus 16, which is large. This can get as large as you want it to get. So here the range is everything from 0 to infinity. Yeah, let's look at, I got a couple more things in mind. Okay. Let's see, keep going the same way. Yeah, go the other way. Good times. All right. Okay, we got like 12-ish minutes. So I want to do one more example with this, which is slightly different. So what if the function instead was the natural log of, let's make it a little different, 9 minus x squared minus y squared. So already, after enough practice, we can see that, oh, I'm going to see a circle of radius 3. That's somehow going to show up here. For the domain, now here the domain is going to be a tiny, tiny bit different than it was in the previous problems. For square roots, we have the whole bigger than or equal to 0 thing. For logarithms, the argument 9 minus x squared minus y squared has to be strictly greater than 0. So that if I add x squared and y squared to the other side, 9 has to be strictly greater than x squared plus y squared. Which means the boundary of the circle is not going to be included in the domain. In both of our previous examples, whether it was all the stuff inside the circle or outside the circle itself was included as part of the domain. For the previous problem, it was all the stuff outside and the boundary. The one before that, it was all the stuff inside and the boundary. Here, we're not going to get the boundary. So here, our domain is everything. Well, actually, let's draw the picture. Circle of radius 3. I don't know why I'm being quite so precise here. Ah, shoot, I messed up. It's not that I drew a bad circle, it's that I drew too much circle. I don't want the circle as a boundary. So what I'm going to do is I'm going to draw a dashed circle to indicate that that boundary is not included. Regardless of if it's the stuff inside or the stuff outside. Let's see, if I check the point 0, 0, 0 plus 0 is less than 9, so it is the stuff inside. So there's my domain for this function of two variables. You could also write it as, this is probably the best way to write it, the set containing the pairs of points x, y, such that I would write it as x squared plus y squared is less than 9. But you could write any of these things, that'd be fine as well. Here, the range is a little bit more interesting. So, logarithmic functions generally have a range that is everything, right? If I look at just y equal to natural log of x, I know it looks like this. It does this kind of deal, 1, 0. And it goes down to negative infinity as x is closer to 0, and it goes up to positive infinity as x is really, really large. Or, as I would like to really say, the logarithmic function gets very negative as the argument gets closer and closer to 0. The logarithmic function gets very positive as the argument gets very, very large. So the question is, well, there are two questions really. How large can the insides get? How small can the insides get? So here's what I've got. I know that I've got this. I know that 9 minus x squared minus y squared has to be greater than 0. That's part of the domain. And I also know that x squared plus y squared has to be less than 9. So I've kind of got this. I've got x squared plus y squared. Oops, sorry. It's terrible. I've got x squared plus y squared trapped. Always bigger than or equal to 0, no matter what, right? That's just true. X squared plus y squared is greater than or equal to 0. But for this particular problem, our domain says x squared plus y squared has to be less than 9. All right, but now I really want to look at what's doing with this. So I'm going to say, okay, well, I'm going to try and make this look like that. And there's a number of ways you can do it. I mean, you could just, here's what I'm really thinking. I can see that x squared plus y squared is between 0 and 9. So 9 minus it is also between 0 and 9, because 9 minus 0 is 9, and 9 minus 9 is 0. But you could also do the work. Right? You could say, okay, do a negative on everything. Negative 0 is bigger than or equal to negative x squared plus y squared is bigger than negative 9. And then you could add 9 to everything. So 9 minus 0 is bigger than or equal to 9 minus x squared plus y squared is bigger than 9 minus 9. So it looks like the insides of my logarithm are between 0 and 9. Now if I take the log of everything, the natural log of 9 is bigger than or equal to the natural log of my stuff. Is bigger than the natural log of 0 goes down to negative infinity. So since my stuff inside the logarithm gets really, really close to 0, the logarithm goes down to negative infinity, right? And we've got this graph, right? There's my logarithmic graph. We're getting close to 0, we're going down to negative infinity. but we only get to, our insides only get to be as big as 9. So we're actually getting stopped right there at 9 comma natural log of 9. So our range is as low as negative infinity all the way up to, we stop at natural log of 9. That looks like it's kind of hard to see. So I will try to write a little bit bigger. So here our range is negative infinity up to natural log of 9, inclusive of natural log of 9. Okay. Let's look at, I feel like I had one more that I really wanted to do. Sure, that one's kind of funky. Time is, okay, we got time. So let's look at this one, which is different finally. F of xy equal to the square root of x times y. Seems a little weird, but again, we know the usual stuff, right? We were going to say, well, okay, the insides have to be greater than or equal to 0. So xy greater than or equal to 0. Now, for a product to be positive, well, a product of two things to be positive, they either both have to be positive or both have to be negative. So you either have option 1, x is greater than or equal to 0 and y is greater than or equal to 0. Or option 2, x is less than or equal to 0, y is less than or equal to 0. That's kind of it. So if we're looking at the domain here, well, it's going to be everything in the first quadrant. And everything on the axes as well. And everything in the third quadrant. That is our domain here. It's everything where they're both the same sign, essentially. Okay, seems a little strange. How would you write that? Good question. I don't really have a good answer. I would probably say the domain is a set containing all pairs x and y, such that I might write all this. I might write x and y have the same sign. I might actually write out words. For the range, well, what do we know the bottom of the range is? How small can this square root of xy be? Anybody? Anybody? You can type it in if you want. It's a one type entry answer, or I should say a one keystroke. No takers? Nobody? Okay, I'm gonna, so first day is all right, but eventually I'm gonna expect a little more, what's the word I'm looking for? Interaction, engagement. Kind of lonely at home here. I want to hear you guys talk every once in a while. Okay, so 0, right? 0 is the bottom of the range. Square roots can't get smaller than 0, but this definitely can equal 0 here, because x could be 0 or y could be 0. So I would say our range is probably, well, I can certainly get as small as 0. And can I get as big as I want? Well, yeah, because if y is 1, x can be anything, and the square root of anything can be as large as we want it to be. That's our range here. Probably out of time. Yeah, all right, let's call it a day on that, but let me come back and sit down for a second. So those are some domain and range problems. I can certainly, so my plan for this afternoon is to make some videos that are between 5 and 10 minutes long, maybe, I don't know how many, 3, 2, 5. I don't know really what I'm going to do exactly. But what I will say is, if there are things you would like to see me do, like more domain and range problems, let me know. Or if there are other things like limits or continuity, sorry, I should say limits of multivariable functions or continuity of multivariable functions. If there are specific things you want to see from me, either write it in the chat right now or send me an email, or there was a third option. Oh, start a discussion on Canvas. Also, starting a discussion on Canvas would count as a point towards your participation grade for this class, which we'll talk more about at the end of this week or the beginning of next week. So are there any last questions before I let you guys go? It's going to be an interesting quarter, that's for sure.
Oh, I had a question.
Sure.
About, like, why do you write with that squiggly thing? I don't know what it's called.
This is called a brace?
Yeah.
Yeah, it's so if on your keyboard, it's the thing above the bracket on like the shift command, like this thing here. I'm going to type it in the chat, sorry. So like I'm typing, so this, oops. Sorry, just one sec. Switch to that. Sorry, I'm doing the one on the previous page. So here's how you can write out the domain. So those braces there, the squiggly things, those are called set notation. So it's the set containing, that's what the braces mean, all the coordinates, that's what the parentheses are, X and Y. The vertical line is a substitute for the words such that, and then whatever follows after that is a description of the condition that you need to be true to be in the domain. So that's kind of notation there. And I'll try and use that more, and I will practice kind of talking about it in the videos I might make later today. Good question. Any other questions? You guys are also welcome to have your video on if you want. You certainly are not required to. But if you want to wave for a moment at me at one point, I wouldn't mind at all. Again, you're welcome to talk. And I will post this video to Canvas, I think fairly soon. I was able to get the one for the last class up right away. But I should let you all go because it's 2:01 and this class is over. So again, email me, start a discussion, or yeah, that's it. And I will try to make some relevant videos for you guys today where I do some fun math. I feel like the board looks better than the document camera, but if you guys have differing opinions, you can let me know. All right, I'm gonna end it. Oh, sorry, one last question. For the range of the square roots, the lower bound is, oh, well, I would say for the square roots, the lowest it can be is 0, but it could be something higher. For example, you could have a function. It's a good question. And I'll do this example or an example like it later. That's the square root of x squared plus y squared plus 9. Then the domain would be everything because x and y can be anything. There's no way it's going to get negative inside the square root. But the range would be everything that's bigger than 3 because the smallest this can be is when x and y are both 0, and then the value would be 3. So here the range would be everything from 3 to infinity. So 0 is the lowest possible value for the range when you've got just a square root of some stuff, but it doesn't mean that it is the bottom of the range. It might be a value that's higher than that. Good question. All right, I really should let you guys go. If you have other questions, shoot me an email, start a discussion, and I'll talk to you all later. It's been fun.